Simplifying radicals. We'll be simplifying radicals using the division property of square roots, which states the square root of a divided by b is equal to the square root of a divided by the square root of b. What is the simplified form of the square root of 64 divided by the square root of 49? I recognize both of these as perfect squares, so I'm going to rewrite this as the square root of 64 divided by the square root of 49. The square root of 64 is 8, and the square root of 49 is 7. So the simplified form is 8/7. What is the simplified form of the square root of 144 divided by 9? Again, I recognize both these as perfect squares, so I'm going to rewrite it as the square root of 144 divided by the square root of 9. The square root of 144 is 12. The square root of 9 is 3. 12 divided by 3 is 4. So the simplified form is the number 4. What is the simplified form of the square root of 8x to the third divided by 50x? Well, I don't recognize any perfect squares here, so I'm going to first reduce this underneath the radical. 8 and 50 can both be divided by 2, so that'll give me 4 over 50 over 25, which are perfect squares. And then I can go ahead in this instance and reduce. I have x to the 3 on top and x in the bottom, so that'll just give me x squared on top, another perfect square. So again, I remember that this is equal to the square root of 4x squared divided by the square root of 25. Now I can simplify each radical. The square root of 4x squared is 2x. The square root of 25 is 5. So 2x divided by 5 is the simplified form. What is the simplified form of the square root of 36a divided by 4a to the third? So I recognize these as perfect squares. So in this instance, I can go ahead and reduce the a's, or I can do that later. So I'm going to go ahead and rewrite this as the square root of 36, and I'm going to divide this out and make this a squared in the bottom. So 4a squared in the bottom. So the square root of 36 is 6, and the square root of 4 is 2, and then the square root of a squared is a, which is 3 divided by a. All right, so we've been simplifying radicals, and the rule we've been following is that we know that no perfect squares are allowed under the radical. Another rule in simplifying radicals is that no radicand in the denominator. That means we need to rationalize the denominator. And we're going to do this by taking the property that anything over itself is equal to 1. For instance, the square root of 5 times the square root of 5 is 1. The square root of 3x divided by the square root of 3x is 1. We're going to use this property to simplify the radicals, or rationalize the denominator. And our goal into doing that, how we rationalize the denominator, is we try to make a perfect square in the denominator. So we're going to multiply the expression by whatever's in the denominator. So here we have the square root of 2. And since I know anything over itself is equal to 1, I'm going to multiply 6 divided by the square root of 2 by the denominator, the square root of 2 over the square root of 2. So I've just multiplied this by 1, so I haven't changed the value. But I'm creating a perfect square in the denominator. So let's multiply the numerator. I have 6 times the square root of 2. Now the square root of 2 times the square root of 2 is the square root of 4. So 6 square roots of 2, and the square root of 4 is 2. I can further reduce this. 6 divided by 2 is 3, so 3 square roots of 2 is my simplified form. All right, number 5. What is the simplified form of the square root of 3 divided by the square root of 7? Well, this is not simplified because I have a radical or irrational number in the denominator. I need to rationalize the denominator. And I'm going to do that by trying to make a perfect square. So I'm going to multiply the numerator and the denominator by the denominator. So the square root of 7 over the square root of 7, which is 1, that's allowed. Now I'm going to multiply my numerator, which is the square root of 21. And my denominator becomes the square root of 49. Which equals the square root of 21 over the square root of 7. So the square root of 21 divided by the square root of 7 is a simplified form. Number 6. What is the simplified form of the square root of 2 divided by the square root of 3? Again, this isn't simplified because there's a radical in the denominator. There's an irrational number in the denominator. We need to rationalize that denominator by multiplying something by something that is 1. So we're going to multiply whatever's in the denominator so we can make a perfect square. So we're going to multiply the square root of 3 over the square root of 3. And that's going to give us the square root of 6 over the square root of 9, which is equal to the square root of 6 over 3. If we've rationalized that denominator, we have a rational number in the denominator. Number 7, what is the simplified form of the square root of 7x divided by 3? Well, keep in mind this is equal to the square root of 7x divided by the square root of 3. Again, we're not allowed to have a radicand in the denominator. We need to rationalize this irrational number. And we're going to do that by multiplying by whatever's in the denominator. So the square root of 3 over the square root of 3, which is going to give us in the numerator the square root of 21x, which is simplified. In the denominator, we're going to have the square root of 9, which we can simplify. So in our numerator, we have the square root of 21x divided by 3. And number 8, what is in simplified form of the square root of 5 divided by the square root of 8x? This one's a little different. We can't have a radicand in the denominator. We need to rationalize this denominator. This one has a variable. So let's keep in mind when we're rationalizing a denominator, we're trying to make a perfect square in the denominator. So we're going to multiply whatever's in the denominator, which is the square root of 8x. And we're going to do that square root of 8x over the square root of 8x. So in the numerator, that gives me the square root of 40x. And in the denominator, that gives me the square root of 64x squared. So I know the perfect square, a factor of 40 is 4. So the square root of 4 times square root of 10, which is 2 square roots of 10. And I have an x in the numerator. And in the denominator, I've created this perfect square, so it's 8x. I can reduce more because the 1 cancels and this becomes a 4. So in the numerator, I have the square root of 10x, and in the denominator, I have 4x.